Okay, in this particular lecture, we'll be looking at types of numbers. This is a very important topic which you must know. We have different types of numbers in mathematics. So below are the types of numbers we have. Note, all these numbers were not discovered at the same time. They were discovered as men advanced in the study of mathematical concepts. The very first type of number that was discovered are called the natural numbers. Natural numbers are set of counting numbers. Example, 1, 2, 3, 4, 5, 6, and so on. The numbers you use in counting are called natural numbers. These numbers are used to denote positions, such as first position, second, third, fourth, fifth, sixth, etc. They are used to denote positions. These are called natural numbers. So natural number system is usually denoted by this letter n. That's the Greek symbol for n. Okay, after this, another number system, another type of number was discovered, and these numbers are called the integers. These integers are set of negative and positive whole numbers, including 0. Check it very well. The natural numbers, there was no 0 included. So, but in the integers, they are set of negative and positive whole numbers, including 0. Example, minus anything, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on. So whenever you see negative numbers, especially please, negative whole numbers and positive whole numbers, they are called what? Integers. I want you to take note of something. In the set of integers, you can see natural numbers there. It means that natural numbers are present in the integers. So we can give you a theorem that states that every natural number is an integer, but not all integers are natural numbers. That's a conclusion we can draw. Okay, the set of natural numbers are denoted by the letter Z. Please look at the particular type of Z. Let's look at the third type of number we have. The third type of number we have is called the rational numbers. The rational numbers are a set of numbers that can be expressed in the form A over B. That is like a fraction, where A and B are both integers and B is not equal to 0. If B is 0, the fraction becomes undefined. That means the denominator must not be 0. So whenever you pick two integers together and divide them, it forms a rational number. Now, this set of rational numbers, example, we have 5 over 1, you can see 1 over 2, 10 over 2, 9 over 4. These rational numbers are formed whenever two integers are divided with each other or by each other. The set of rational numbers are denoted by the letter Q. That's the symbol we use in denoting rational numbers. I want you to also note that every natural number and every integer are all rational numbers. But not all rational numbers are integers and what? Natural numbers. Now, further definition of rational numbers. The set of rational numbers are numbers that can terminate after some terms. And if they do not terminate after some term, they have repeated block. Let's give you an instance. For example, 1 over 2. 1 divided by 2 is equals to what? 0.5. You see, it terminates. Another example, 1 over 4. 1 over 4 is equals to what? 0.25. Simple, it terminates. Now, 26 over 7. If you use your calculator, what do you have? You have 3.714285, 714285, and so on. This is a rational number because though it does not terminate, remember the definition, it does not terminate, but it has repeated block. You can see 71428 repeated, 71428 repeated, another one 71428 71428. That is how it repeats till infinity. So this too is an example of a rational number, because we say that rational numbers are set of numbers that do what? Terminate after some terms. And if they do not terminate after some term, they have what? Repeated blocks. Let's show you another example. 1/11 is a rational number, because 1/11 is what? 0.090909090, and it continues. So you can see the repetition there. Another example of a rational number is 10/3. With your calculator, 10/3 gives you 3.333333, and so on. You can see the repeated block there. So every number that terminates after some term is called what? A rational number. And if they do not terminate after some term but have repeated blocks, they are also called what? Rational numbers. Now, let's look at another type of number called the irrational numbers. These are the set of numbers that do not terminate or do not truncate, and they do not have repeated block. That is, their decimal digit continues without reoccurring. Now, you hear the word rational and you also hear the word irrational. That means irrational means something that is not rational. So it is a direct opposite of a rational number. Now, let's look at some examples of irrational number. Example, pi, which you know. Pi is 3.1415926, and so on. If you look at it carefully, there is no repetition there. There is no block that is repeated. Another example is square root of 3. All these are irrational numbers. There's no repetition. There's no repeated block there. Another example, square root of 2, which is 1.4142135662. It continues indefinitely, but there's no repetition. All these are examples of what? Irrational numbers. The set of irrational numbers are denoted by the letter IQ. Okay, let's look at the next number system called the real number system. All the set of numbers you know in this life are classified under real number system. So we say that real number system are a set of all possible numbers. It is made up of both the rational and irrational number system, and it is usually denoted by the letter R. Okay, the last number system we have is called the complex number system. The complex number system are a set of numbers which are usually represented or denoted in the form A plus IB. When you come into complex mathematics, you will understand this better. Okay, they are always in the form A plus IB, where A and B are real numbers and I is equals to square root of -1. And that is always called an imaginary number. It is usually denoted by the letter C. Now, let's help you to understand this. Example, if you have square root of -4, now check it with your calculator. It will show you math error. Calculator can't solve this one. Now, this square root of -4, we can solve it by splitting it into 2. This equals to square root of -1 times square root of 4. Now, square root of -1 we told you is I. That is an imaginary line, imaginary number, please. Then square root of 4 is what? 2. So this will give us I2. So it means square root of -4 is equals to what? I2. Of course, I2 means 2I. It's equivalent to 2I. So whenever you see a particular number that has or that is included with I, it means it's a complex number. Now, example, square root of -16 is the same thing as -1, square root of -1 times square root of what? 16. Square root of -1 is what? I. Times square root of 16 is what? 4. So we now have what? I4, which is equivalent to what? 4I. So these are examples of complex numbers. Now, let's talk about classifications of the real numbers. Real numbers are classified into 2, we have odd numbers, and we say odd numbers are numbers that cannot be divided exactly by 2. Examples are 1, 3, 5, 7, 9, 11, and so on. All these are examples of what? Odd numbers. Another classification of real numbers is what? The even numbers. So even numbers are those numbers that can be divided exactly by 2 without a remainder. Examples of even number are 2, 4, 6, 8, 10, 12, 14, 16, etc. Okay, we've come to the end of this particular lecture. Let's give you something to play with. Now the question is 1. What type of number is 10i? Comment your answer in the comment space below. Number 2 says, what type of number is square root of 7, which is 2.6457511311? Okay, we're going to look over it and then reply you. Thank you very much for your attention. The next lectures, we shall be looking at factors, multiples, and primes. Goodbye.